This lesson is on multiple derivatives. And so far in this course, we've just taken the first derivative. We've just taken the derivative one time. We have some special notation for second derivatives. We tend to stick in this course to y double prime f double prime of x, and then this notation that's d squared y over dx squared. Because of the 2's, you can recognize that it is a second derivative. And you'll notice by the powers and the notations, if there are multiple derivatives, the different textbooks and different tests will be able to explain to you which one that they won't pass to. But we do work a lot with the first and second derivatives in this class, so just familiarize yourself with those. So for our examples, we're going to find the second derivative, and in this case, we were given y equals 5x to the fourth minus 3x cubed plus 7x squared minus 2x plus 8. Nice long polynomial, but everything is a power rule here. That's not always the case, but just to show you the basic concept here, we're going to say that y double prime, or excuse me, y prime, sorry, y prime is 20x to the third minus 9x squared plus 14x minus 2. I just did a power rule there. Remember that the derivative of 8 is 0. So that power rule for each step just landed us here at this new polynomial that's one exponent down or one power down from the original. The second derivative, we can just go on and do the same thing. So it's again power rules. So 3 times 20 is 60. I have x squared. 9 times 2 is 18 x, and then plus 14, the derivative of 2 being 0. So notice it gets shorter each time because those plain numbers on the end will go to a derivative of 0, and the power goes down each time when we're dealing with these polynomial type situations. But this would be my second derivative. Not everything's going to work out that nicely. Obviously, cosine is not going to drop something each time. It's going to go to sine. Sine's going to go back to a version of cosine, and so on. This is a product rule. So this will be probably the first time that we really need to use algebra and simplify after we find the derivative to make finding the second derivative a little easier. So I'm going to go ahead and do the product rule for my first derivative and say first times the derivative of the second, which would just be 2, plus the second times the derivative of the first, and the derivative of cosine is negative sine. So I'm going to call this still the first derivative because I'm not taking a derivative, I'm just using algebra, and I'm going to rearrange this. Cosine of x times 2, I'm going to write as 2 cosine of x, so that I don't think of it as a product typically anymore. And then I can leave this like this, or I can take the negative and distribute it through this other parentheses. I think I'm going to leave it because either way it's going to be a product rule when I do this. So I'm just going to leave this part for right now. And I'm going to take that second derivative. So the first part's easy. I'm just going to bring down the 2, and then the derivative of cosine is negative sine, so that'll make it negative 2 sine. And then the second part, as I was talking about, I've got another product rule. So first times the derivative of the second, and the derivative of sine is cosine, so this will be negative cosine. So first derivative of the second plus second times the derivative of the first, which would be 2. So again, I'm going to simplify here. I have that negative 2 sine x. I have the 2x minus 3 times the negative cosine of x, and then over here I have this 2 that I can bring to the front of that and have negative 2 sine x. Now sometimes you'll be asked to go further to like the third or fourth derivative, and in that case I would go ahead and combine this negative 2 sine x with this negative 2 sine x and make that a negative 4 sine x plus the 2x minus 3 times negative cosine x, because it would just simplify the problem to move forward. But here they just asked us to stop at the second, so this would be fine. And you may find a version if you were in a multiple choice situation where they've distributed that negative through, or maybe not. So we'll move on. Okay, on this one again we're going to go to the second derivative. So my first derivative is going to be a chain rule, so I do 3 parentheses to the second and keep that inside the same. And then the derivative of the inside would be 6x. Again, this is a situation that I want to simplify first. I'm going to bring this 6x to the front with this 3 and call that 18x. And then to get to the second derivative, I'm going to have to do a product rule. So this is my first, this is my second, because now I have x's in 2 pieces. So first derivative of the second is another chain rule, plus the second times the derivative of the first, which would be 18. And again, they didn't ask us to go on and keep going to get to a third or fourth derivative, but I wanted to just show you what you can combine. The plus kind of separates it into 2 parts because everything on this side is multiplied and then everything on this side is multiplied. I can combine the things that are multiplied because it doesn't matter what order they're in. So I'm going to take the 18, the 2, and the 6 and multiply those. So 18 times 2 times 6 is 216. I have x and x, so that's x squared. And then I have the 3x squared plus 2 still in parentheses. And I could even distribute through that if I wanted to. And then over here, we would typically move that 18 to the front. And so there's just other things that I could do past that, but I wanted to show you what was legal to combine there. Okay, for our last example, I wanted to show you what a multiple choice question might look like when they're asking us to do multiple derivatives. And this one gives us this function to the 4th power, and they want to know the 4th derivative at 1. So I'm going to be plugging 1 in. But I want you to notice what these answers look like. 4 factorial and then powers of 3 or 5. Remember that 4 factorial means 4 times 3 times 2 times 1. So anytime you see that, we're getting that there. So let's come over here and work this out. So my first derivative of this, I'm going to bring chain rule, so I'm going to bring the 4 to the front, and it'll be to the 3rd power. And I have 2 plus 3 to the x, and then the derivative of the inside is 3. Because of the way these are written, I'm going to not multiply the 4 and the 3. I'm going to bring them both to the front though, because I need to still think of this as a chain rule and not a product rule because the outside stuff doesn't have x's with it. So it's still a chain rule, just, you know, if that was a 12, we would just say 3 times 12, but because we're trying to make it look like this, I'm not going to multiply those. So my second derivative is another chain. I'm going to take that 3 multiplied in front, so I'm going to have 4 times 3 times 3, and then my parentheses to the second. And the inside stays the same, and then I have to multiply by the derivative of the inside, which would be 3. That's going to stick another 3 on the front. I'm not taking the derivative here, I'm just rearranging, so I don't change the amount of primes. Okay, so I'm to the second derivative, I got to make it to the 4th. So the 3rd derivative, another chain rule, I'm going to be multiplying by the 2. So I have everything that I have here. This will be to the 1st power, and then I get a 3 from multiplying by the derivative of the inside. Okay, and again, the only reason that I'm writing these out and not multiplying is just because it's multiple choice and I need my answer to look like this, because on a situation like this, you would not have your calculator to be able to plug and chug and figure out which one it matched. You have to be able to do it by hand. So again, I'm going to rewrite and put that 3 from the back in the front. And then my 4th derivative, and sometimes they use Roman numerals here. My 4th derivative, I don't have a power here. This is kind of like having a number times like sign or whatever. You bring that number down, so I'm bringing all that stuff down. and then multiply by the derivative of the inside, which will be another 3. And it's crazy because, or it feels crazy because the x is gone and they're wanting to know at 1, and by this point we're just getting a number anyway, so it's at any x value. But let's see which one it matches. Obviously it's not 0, so we're going to toss that. 4 factorial is 4 times 3 times 2 times 1. So I'm going to pick 4, 3, 2, and obviously there's always an imaginary 1. So the 4, the 3, and the 2 here are going to make a 4 factorial. And then I have 1, 2, 3, 4 3's left, so that would be 3 to the 4th power. And so then I can see that my answer would be choice C. So that's how it might work in a multiple choice situation. And you now have a worksheet to work on to answer these questions. That concludes this lesson.